Hello everyone, this is the third video and the final video of 1.3 quantities of atoms. In this video, we'll be looking at the second part mainly, which is the second box in this science understanding table. The relative atomic mass of an element is determined from all the isotopes of the element. So it will refer to something like why mass number of each element on the periodic table has got the decimal number. Why not the whole number? The slide that we'll be looking at is the 10th slide. All right. So we'll talk about what's called the relative atomic mass. The symbol is AR. So it is an expression of an atom by comparing to its mass to other atoms. Now, when we say other atoms, we use carbon as the normal standard place. So, I guess in the past that was readily available, and it was very easy to make it into purely carbon-12 only. So that's where we started. So the mass of atoms are compared to the mass of carbon-12. Relative mass of carbon-12 is 12. There is no carbon-13 or 14. So purely 100% carbon-12, if you had one more of that, it will always make 12 grams, okay? 12.00. Whereas the relative atomic mass, so if you look at other element or other isotopes of carbon, you can call that they will be relative atomic mass to carbon-12. So the mass of an atom relative to mass of carbon-12, for example, carbon-14 would be 14/12 of the mass of carbon-12. If it was hydrogen atom, no deuterium, no tritium, that would be 1/12 of mass of carbon-12. So we are talking about per atom or per mole. Other way should work. All right, next slide. Thank you. Now, this mass number for each element can be figured out by looking at percent abundance of isotopes. For example, carbon. Now, we've been using carbon as example quite a bit. So on here, you can find carbon-12 having 98.9, and carbon-13 1.1%, and carbon-14 as 0.1% or less than 0.1%. So they are the percent abundance of each isotope if you had a bunch of carbon. Even if you had pure carbon, if you're looking at naturally occurring ones, carbons would have that percentage for each isotope. So let's try drawing this diagram and names carbon-12, 13, 14, as well as each percentage. They are the percent abundance of each isotopes. Abundance refers to the occurrence of that isotope relative to other isotopes of the same element. So if you're looking at carbons, how much more of carbon-12 exists within the carbon element compared to carbon-13 or 14. So they are in percentage. The total would always be, of course, 100%. In terms of lithium, if you're looking at lithium metal element, 7.6% would have 6 as its mass number for that isotope. And 92.4% would have 7 as its mass number for that particular atom or isotopes. If you put them together, on average, you should have, well, if you look at the periodic table, it says 6.941 So 6.941 comes from the average of those two isotopes. Okay, continuing with relative atomic mass. Relative mass of carbon-12, as we said, it's going to be 12.00 grams per mole. And that's the unit we use as well because we're talking about atomic mass. So it's probably more convenient to have one mole just as a bunch instead of just looking at per atom. the relative atomic mass of carbon. So that's a number that you would see on the periodic table. It should say 12.01 grams per mole. So that's the relative atomic mass of carbon. And why does it have 0.01 part? Because of the percent abundance. Because that's including other isotopes other than carbon-12, carbon-13 and 14. Hope that makes sense. Okay. Now, finally, relative molecular mass. Relative molecular mass. Now, if you have forgotten about what the molecule means, molecules are something that's having more than one atom. Now, molecules can have more than one type of atom as well. It's not going to be a continuous structure. If you had ionic compound, so something that has metal and non-metal, that will be ionic. That will be making large structure, not a molecule. Molecules usually small. They are not continuous. They are usually separated from each other. They don't really want to associate as much as ions or things like carbon can make. Carbon can make covalent lattice, covalent lattice, or silicons as well. They can make rocks, so they can make covalent lattice as well. If you have got small things like oxygen molecule, like O2, or H2 or CO2, they are all molecules. Okay? So when you look at those molecules, you can also talk about relative molecular mass. Molar mass is another word used for molar mass. Okay? The relative mass of molecular compound can be expressed as mR, and it is called relative molecular mass. For example, relative molecular mass of methane, which is CH4. Now you can figure out its molar mass or molecular mass with just by looking at the atomic mass number and then adding them up. So for CH4 methane gas, you have 12.01, and there are 4 lots of 1.008, which is the mass number for hydrogen. So if you do the bed mass properly, you should be able to get 16.042 as relative molecular mass, also known as molar mass. Okay, that's molar mass. Unit is still in grams per mole because you just multiplied and added things together. Right? Okay, now we'll spend some time to do question 21 to 23 on Essentials workbook, and that's the end of subtopic 1.3.